do my presentation in this mode. I've had problems in the past with Keynote hanging up on the Zoom channel. So I think this would be a more secure way of showing the slides. And as Andreas mentioned, I was a researcher for years doing evolutionary biology, and that research became more and more data intensive and eventually led me into these data related issues, which eventually led me into the GoFair office. The GoFair International Support and Coordination Office has been operating since January of 2018. So we're just over 2 years old. And as the name suggests in the office, it's about supporting and coordinating stakeholders who have an interest in becoming more fair in the data and services that they offer. And so we like to say in the office that we do nothing. We just simply support and coordinate the others who do. What we really try to strive for in GoFair is a kind of a fast track implementation of the FAIR principles. And so I like to start most of my presentations really right at the beginning with the FAIR principles. This is how they were originally published in the original Nature commentary from 2016. It was just a figure item, box 2, in an otherwise a commentary about the need for fair data and services. And although the paper has been widely cited, it's funny because these principles never had any implementation discussion behind them. They were just offered as these very high level behaviors that would be required in order to enable machine actionable FA, I, and R. And when you read the original article, you see that there was really this emphasis on trying to automate these basic functions, let's say these basic data science functions, because right now, most of these actions require human intervention. And just because of the scale and complexity of data these days, it's just not going to be scalable, or it won't be realistic for humans to stay in that loop. So over time, we need to figure out ways of automating FA, I, and R. The principles are proposing things that have to happen in order for machine actionability to be a reality. And as I mentioned, there was at that time nothing said about the implementation priorities or strategies, nothing about the realistic costs or the choices that must be made in getting to fair implementations. So that's why a couple of years later, the GoFair organization came into being. And it was really this attempt to try and coordinate to get smart decision-making on fair implementations. So using existing technologies, or in some cases, developing new technologies that may enable the FAIR principles. And because there's lots of options available to us, there's a need for some kind of coordination to make this go smoother. Some of the issues that might be concerned in going from principles to implementations are, for example, just trying to maximize the reuse of good solutions that are out there. So another way of saying it is to try and prevent the reinvention of the wheel, which happens all the time. We want to minimize costs. We want to maximize interoperation between not only within domains, but between disciplines and between data domains. And we can do that, I think, effectively when we have some level of coordination. And then there's all kinds of other value propositions you can think of as well. Just a couple more things about the principles to kind of see that they are, in fact, a very useful guide in choosing implementations. One thing I like to point out is that metadata is everywhere in the FAIR principles. It's clear that there would be no fair data without machine actionable metadata to guide these machine operations. The metadata is the thing that actually is going to be driving the interactions between data and services. So more and more, we have to take metadata seriously. And it's even, I would be tempted to say that for fair data, it's maybe even a higher priority to verify your metadata than your data sets itself. So there's a lot we can say about metadata, but I just wanted to highlight at least how important it is in how the principles are written. You can also partition the principles in other ways that make them useful for thinking about implementations. What I've done here is highlighted principles that are referring more to sort of technical infrastructure type issues from principles that are much more data or metadata domain specific related. So that's the distinction, the red and blue distinction here. I'm showing the yin yang symbol because these are really two very separate, but yet in some way inseparable components to fair data. You need both in order to have real fair data and services, but they are themselves different in implementation and in sort of the skill sets or the technologies behind them. Another way of saying this, however, is, when we refer to the technical infrastructure, this could be, for example, the repository that would be hosting some data or service. And so it may be that by choosing your repository wisely, you might be optimizing the number of fair principles that you can get by using that service. So by understanding the level of fairness for different repositories, you can begin to make wise choices about how, as a data provider or data producer, how you can get the most bang for the buck by choosing a repository. The blue components, again, are referring to real domain-specific elements, biomedical domains, geological domains, historical domains. Each of these different topical domains have their own standards in place, their own best practices, and these are these blue components here are data and metadata that need to be built by typically the users themselves in those domains. So whereas the red principles are very generic and can be often satisfied by choosing appropriate technologies, the blue domain, the blue principles are really referring to kind of the idiosyncrasies of different domains. And that distinction will come back a little bit later as well. So that's just sort of the introduction on where we like to start with the FAIR principles. But the rest of the presentation, I'd like to tell you really about two approaches that can help us think in more concrete terms about FAIR implementations. And there's a lot of different ways I could have produced this presentation today, but I wanted to talk to you about the FAIR data point because it's a kind of, it's very much related to how we think about repositories. And I wanted to end with FAIR implementation profiles because these are often, or these are quite related to the FAIR evaluations that you've been doing as part of the work package. So let me start with the FAIR data point, and then I'll end with a little bit about the FAIR implementation profile. So the FAIR data point was initiated as part of a project from 2016, 2017. This is a Dutch research project to try and build a reference implementation for the 15 FAIR principles. So could we find in one kind of technology an opportunity where we could try and tick the boxes on most of the FAIR principles? And the idea for this was okay, we have, according to the FAIR principles, we might have our data and our metadata. These could be in whatever formats. We were going to choose, and considering the I principles, we were going to choose a language for knowledge representation and interoperation. So we chose RDF for this. And so the first step might be to convert your data and metadata into RDF. This would involve building a semantic data model and then looking for ontologies and vocabularies and building your RDF code. This is typically a manual process. So in the project, we used a platform called OpenRefine. This was kind of a data wrangling platform that spun out of Google, but we augmented it with capabilities for adding identifiers, for consulting ontologies, and for incorporating data models, so that we could try to automate some of the repetitive aspects of writing RDF. But the idea was we could go from data and metadata into RDF files, and then we would put these files onto what we call a FAIR data point. And we imagined that if there was a world of FAIR data points, then you could build very sophisticated search capabilities to do some really interesting approaches to findability and reuse. And I'll try and illustrate the thinking behind this. This is what the FAIR data point looks like schematically. It's actually kind of a repurposed linked data platform, if you know that from the W3C standards. But the FAIR data point is basically this API that connects a lot of linked data in this case. So you can access the FAIR data point through normal GET calls. The structure of the FAIR data point is governed by the data catalog. This was another implementation choice we made. You can think of the FAIR data point as really a metadata publication platform, and it's hierarchically structured according to the to DCAT. So in a FAIR data point, we may have one or many catalogs, and in a catalog, you may have one or many data sets. And in a data set, you have one or many distributions. And so here's an example where we have a single data set one, but it has both a text file and an RDF file representation to it. Here's another data set two, and it has another distribution, looks like a CSV file. There's another catalog that looks like it contains image files. And the idea is that through a series of GET calls, a computer, or let's say a machine client, could query these metadata, drilling down until, in the case of data set one RDF distribution, the computer could actually drill down to a row and a column in that RDF file and find a particular data point. So maybe it's a blood pressure reading, but the computer would automatically know then that this is from some kind of patient located in a certain place. It would know the units of the blood pressure reading, and it would know what it was allowed to do under the privacy restrictions of this. So the FAIR data point would begin to allow for using machine actionable metadata for the implementation of a lot of these different FAIR principles. Here's an example of a FAIR data point in action. This is kept by my colleagues at the Leiden University Medical Center. And it's just a FAIR data point that keeps track of the publications that we had from this group. So you can see a bunch of metadata here. This is all human readable, but behind it is in fact the RDF machine actionable metadata. Here's catalogs. If you click on any of these catalogs, you would get to the data sets. If you click on those data sets, you would get to the distributions. And if you click on those distributions, you would actually get to the data sets itself. Here's another example of a FAIR data point run by a community that keeps track of data and registries for rare diseases. And this has another human user interface, but again, it's machine actionable behind the scenes. I'll mention one other thing. in the FAIR data point, you can host, for example, just metadata that point to data wherever they may be. So the FAIR data point can act in a very distributed way as well, pointing to data sets that may be in different data repositories with their own access protocols and everything. But it's just to say that the FAIR data point can host both data and metadata, or maybe just metadata itself. I'm going to take this example from Mark Wilkinson, and this was an idea of, okay, if we had this world of FAIR data points, what would we be able to do? So here's to contrast to a Google search now. If I want drugs for cancer research, so say inhibitors to the human protein of P65, I can type in, a search. I get 500,000 hits. Most of these are research articles, and it means that I would have to read a lot of articles to get to these inhibitors that are buried somewhere inside. These inhibitors may be linked by supplemental data. They may be in figures. So it's very difficult for the machine to actually locate these inhibitors and interpret these research articles. In a world of FAIR data, the query could be much more elaborate. And we could say, for example, find me all known low molecular weight inhibitors of the human P65. So the questions can be much more nuanced. Separate the list based on those that were found in curated databases from those in self-deposited archives. Keep track of the licensing and citation information so that I can reuse these data. If the data is relevant but not public or somehow protected, then give me the protocol I need to actually access this. These elements in this query are composing, in a lot of interesting surveys on data science. This is composing, up to like 80% of the time of a data scientist. These are questions and operations that can and should be automated just because an inordinate amount of time is spent trying to do these things manually, and it just won't continue to scale the way things are going. So that was all theoretical. On September 5, 2018, Google launched its dataset search tool. And just for fun, we typed in our biosemantics group, LUMC, and Google found our FAIR data point. And when we clicked on this, Google provided for us not only the machine actionable code on the left, but the human readable version on the right. So this was kind of stunning. We thought, well, there would be another research project involved in building a search engine on FAIR data points, but Google was already able to do this for us. And that was sort of the state of the art up until about 2 months ago. And then the COVID-19 pandemic came upon us. There's a new implementation network now in GoFair called the Virus Outbreak Data Network. And there's already 2 funded projects in this implementation network with the goal of building a FAIR data point that would host what we call case report forms for patients who have been diagnosed with COVID-19 symptoms. And so I just want to highlight for you how we will actually try to implement these FAIR data points. And so you can see, what is also for us kind of the first real world, kind of sustained application here of the FAIR data point. So here's the FAIR data point in red, hosting metadata. And the idea is that these metadata are pointing to these electronic case report forms. We built an RDF form based on the World Health Organization standard. And these can be hosted at various locations, hospitals, whatever. Our first project is working with 6 African countries to set up FAIR data points for some of the hospitals located in those countries. Again, the metadata is following the DCAT standard. We're working intensely with Uganda and we will of course be using standards and vocabularies related to the COVID-19 space. The idea is that we will be working with hospitals on the ground to verify some of the patient record data so that it can be properly exposed in an electronic case report form and made available to the FAIR data points. What we can envision then, at least in Africa, but certainly beyond, is a network of FAIR data points that would allow for algorithms to visit those FAIR data points and to, in real time, keep track of the growing information about COVID-19 cases in those countries. Yeah, and we're setting up processes now to help with this verification, going from hospital record systems into the electronic forms. And we have what we call metadata for machine workshops that help people on the ground to do this verification in kind of an expedient, efficient way. So that's all I'm going to say about the FAIR data point at the moment, except for maybe one other element, that as a metadata publication platform, the FAIR data point was also envisioned as a way of exposing from any repository appropriate metadata that would be of interest in the FAIR data point, and thereby potentially or hopefully making that repository more fair or reaching higher levels of fairness, not by really changing the technology or the implementations in that repository itself, but just simply by exposing some elements in the FAIR data point context. So it was sort of viewed as a lightweight layer that could be added to a repository to help in the verification. Okay, so we can, I'm happy to take questions on the FAIR data point, maybe at the end of the talk. But I want to switch now to what we call the FAIR implementation profile. And all of this started because GoFair felt the need or had the mandate to help coordinate decisions on implementations towards FAIR. And what we saw happening was that starting with the FAIR principles, there was a large number of different domain communities coming to GoFair, sort of broad spectrum communities from the hard sciences all the way to the humanities, to industry requirements, to governments. But all these domain communities were trying to figure out how they were going to implement FAIR. And what we saw was a kind of a matrix or a constellation of communities, and then the resources they were using to implement FAINR. And we started to keep track of those resources, and we realized that there could be a way of organizing this to help communities make better, faster decisions. So any new community now that comes to GoFair can be presented with a list of resources that other communities have already chosen to GoFair. So any new community or repository that wants to become more fair has a large list of choices on implementations that they can make for themselves. If they don't see a resource that they need, maybe a new technical vocabulary or ontology that would serve some purpose, then that community may accept a challenge to build that resource itself, to build that new ontology or vocabulary, for example. In GoFair, we encourage the reuse of resources as much as possible. So we show this big green arrow, and we encourage the choice of reusing. And then if we can register these choices and communities can make declarations about the choices they have made, then we begin, I think, a process where we can do, we can help communities optimize their decision-making going into the future. So we did this already for our 20 or 30 FAIR implementation networks in GoFair. And what I'm showing here is essentially this matrix of communities and the resources that they use to go fair. And I'm showing it now as a network. The purple nodes here are the communities themselves, these different implementation networks. The blue nodes are representing the resources that they've chosen to implement the FAIR principles. And the yellow nodes are those resources that are being used by more than one domain community. And when we looked at it this way, we thought, okay, the job of Go Fair is to increase the number of yellow nodes. It's to increase the number of resources that are being reused by communities. This would save on redevelopment of resources on the one hand, and it would also drive interoperability on the other. And from such analyses, you can begin to see very interesting opportunities here. So here's a community, for example, in the upper left corner, that's not, in this formulation, is not connected to the rest of the community. So this community could begin to reconsider its implementation choices to something that's being more widely used, and then maybe therefore automatically drive its interoperability with the rest of the FAIR community. This initial idea has been now formulated by a working group in Go Fair that's been very dedicated over the last year and a half. I'm really impressed with the dedication here. But the idea is to develop a questionnaire that would prompt these different stakeholder communities to list their FAIR implementations for each of the FAIR principles. And we have this third generation questionnaire now that we're becoming much more satisfied with. We've built an ontology that describes what a community is, what a FAIR implementation choice is, what resources are, how they're connected to the FAIR principles. We're expressing all of this information in a machine readable format, in this case, nanopublications, using FAIR sharing as a source of identifiers. And we present all of it in a very convenient user interface, reusing the Data Stewardship Wizard questionnaire. So it's a very nice online interface where you can answer these questions in the questionnaire, and the information is automatically recorded in a machine actionable way. So there's a snapshot of the core ontology. We have communities and resources there. Those are the two basic components. Everything's connected to the FAIR principles. This is the version 3 questionnaire I mentioned, but it's expressed in this conversion matrix, in the Data Stewardship Wizard. Here's a link to the matrix, and here's a logon credential. You can go through, I think it's a list of 20 questions or so that they're listed here. And by answering the questions with prompts and auto-completes from FAIR sharing, you can begin to build your own FAIR implementation profile for your repository, for example. And then you can compare that, say, to the FAIR implementation profiles of other repositories. This is kind of the next generation view on this. Here's 3 communities in purple at the center with their FAIR implementation choices partitioned by each of the FAIR principles. So we can do some fun and interesting data analytics, but again, all for the purpose of trying to find smart implementation choices in order to drive interoperability. Yeah, we can look at the problem inside out. Here we're looking at identifier systems, so globally unique persistent identifiers that are used by communities. And you see that, for example, DOIs are heavily used, but so are some others. And the question is, why would any repository choose to use one identifier system over the other? And what are the benefits of each? And so just putting all that together, just a couple more slides. This is a schematic view of this FAIR convergence matrix. You see communities listed as columns, and the resources that they're using to implement the FAIR principles are in the rows. And what you see, for example, are these 4 communities either choosing to reuse a resource, call it 1, or not, call it 0. And in this really idealized form, a fair implementation profile is essentially this, this 0-1 profile that just identifies which resources a community is using. So we have 4 profiles here. We can do comparisons. We can begin to think about optimizations. If we focus on the fair implementation profile for community C, we can list the profile. The profile itself is fair data and is a fair data set, and that can be accessed and reused by others. So for example, other communities who may have some intrinsic trust in the quality of the profile for community C may choose simply to reuse that profile for themselves. And the idea is that we could begin to drive convergence onto fair standards and technologies and implementations simply through the reuse of well-trusted, well-proven fair implementation profiles. So I think we can save time on this and maximize reuse and interoperation. There's articles describing this, and you can link to those later. And I want to end here just by saying, what is the fair implementation profile for your own repository? And this is I think a short list of some of the repositories involved in this project. And I think for me, for GoFair, we would love to see what the fair implementation profiles look like in each case. And I really want to tie this back together with the exercise that you've already completed now. The fair evaluation tool that's been used to run evaluations on your repositories is essentially an executable fair implementation profile tool. The fair evaluation you get is checking against implementations that are known to the creators of the fair evaluating service. So in a way, the fair implementation profile is just a declarative statement on your implementations, whereas the evaluation tool is really kind of an executable evaluation of that profile. And that's maybe a discussion we will come back to later. I will end there and be happy to take any questions from anybody. Thanks.
Thank you, Eric.